maybe walk a little bit through kind of BCI history, or maybe more, you could go really far back, I guess, with like just the discovery that there were like electrical charges in the brains and EEG in like the early 1900s, but maybe just even, that, or also just kind of the quote unquote Utah array. If I understand, that was, I think, early 2000s, I believe, where it was like the first real kind of proof that there you could actually essentially have the brain be instructed via an outside device.
Yeah, I think that the Utah array, there have been, over the last 60 years, a lot of kind of one-off examples of neurosurgeons putting in electrodes into different areas and seeing brain responses in response to different stimuli, or stimulating the brain and getting people to perceive something or move their body. But I agree with you that the Utah array, which is basically a bed of 100 silicon microneedles.
Was it related to like a university in Utah?
It was developed at the University of Utah, yeah.
Okay.
And it was actually, the hardware was developed in 1989.
Oh, wow.
Which is really interesting. It wasn't used in humans until the mid-2000s in clinical trials. But one of the things I tell people who are looking to get excited about BCI is that even today, the most impressive BCI trials that have been done with this Utah array that was made in 1989. And so in some sense, like, BCI technology has been arrested since 1989. And so now think about what you used like your dial-up modem for in the late 80s, early 90s. And then as modems like kept advancing on a exponential over the next decades, like what you use your like home internet for now.
Yeah.
And now consider that BCI is still like stuck in the late 80s, and everything exciting that's been eked out of BCI since then has been basically due to the heroic efforts of researchers and cool machine learning tricks.
What was the 1989 kind of breakthrough?
I think it was really just the idea of using microfabrication technologies to create a reproducible array of 100 little microelectrodes that could be accessed electrically.
And is the way that we should think about that is essentially, when you say like electrode, almost like a pin kind of needle?
Yeah,
or?
it's basically a silicon needle, like the same material that a chip is made of. And it's 100 microns at the base, which is 1/10 of a millimeter. And then it gets really small down to, let's say, like 10 microns at the tip. And then so it looks a little bit like a bed of nails, and it sits on top of the surface of the brain, and then it reaches down about 1.5 millimeters into the brain tissue and records from individual neurons. And so the first applications of this allowed people to control robotic hands, control a cursor on the screen. Now there's recently been a really exciting breakthrough at UC Davis, where there is a patient who lost the ability to speak and tries to speak, and the brain implant is able to tell what he's trying to say and turn it into text at 30 to 60 words per minute.
And then what was the impetus for that? Was it so in 1989? Was that actually University of Utah as well?
Yeah.
So what was the researchers' impetus in terms of that? Was it a stab in the dark? Did they actually have very high conviction? They knew the right area of the brain, for example, to put that initial array of.
We've known for a long time that there are sensory areas that encode information like visual and auditory, and there are motor areas that essentially tell the body what to do. And so from recording and stimulation experiments in animals and humans, everyone knew that putting a device into motor cortex would allow you to read out intended motor movement. And I think the initial recordings were done in an area that controls the hand called hand knob. and focused on robotic arm control, imagined movement of a computer cursor, later on imagined handwriting. And even from the first early experiments with the Utah ray in the early 2000s, I think everyone directionally knew that this was going to be successful, but then it's about showing it and then about engineering it to actually work.
So if we take like 1989 and then you starting the company in 2016, was there something that happened where you thought building a BCI company was possible and that's why you started it? Or you just got so fascinated with the space, it wasn't relevant to you whether you thought it was possible or not, you're just going to do it?
I think there have been a convergence of things that have made it possible now that maybe didn't exist in 1989. So in 1989, the data that people are collecting today in BCI experiments would have been very difficult to analyze. In 1989, the system still would have been like computation limited, practically. Now we're in a situation where it's not computation limited, it's not model limited, it's just data limited. If we tomorrow double the amount of data coming out of a BCI, we'll still be able to analyze it. In some sense, like advances in GPUs and advances in AI models have vastly outpaced advances in BCI. Now, actually, it's there's a backlog of 20 years of semiconductor and artificial intelligence research that can be tapped for the BCI field. So there's definitely something available now that wasn't available back in the day. I think that to some extent, someone just had to do it. Someone just had to commit to it, and then obviously put the capital behind it.
Maybe talk through what was the switch that went off where you said, I'm going to build a company in this space.
If we didn't do it, it felt like no one would do it. The only thing preventing patients from having more useful systems, doing more things, was that they were essentially like transmitting data through this tiny little soda straw. And there was no engineering reason why it couldn't be 10 or 100x better. There were also a lot of frustrating limitations of the technology at the time. It involved wires coming through the scalp, the sort of like big things bolted to the skull that looked like 1990s security cameras. And it just felt like a crime that people who are paralyzed, who could really be benefiting from BCI technology as it existed, spread out across different labs at the time, were stuck with kind of shitty solutions.